Alright, so in this video we're going to be focusing on solving using trigs to find missing lengths of a triangle as well as the missing angles of a triangle. I guess this is kind of like your chapter review. I don't know if we'll have time to go through all of this again, so I do want to make sure that I go in detail. The top three things that we're going to focus on for this video and this test is the interior angle sum of a triangle. So IAS, interior angle sum of a triangle, is always 180, and that applies to any triangle of any shape. And that means like a right, an isosceles, an obtuse, a whatever kind of triangle you have, it'll always equal 180, the angles on the inside. We're also going to be using sine, cosine, and tangent, like in this problem here, which is like one of the ones on your test. Sine, cosine, tangent to solve for the missing sides and the angle. And then we're also going to be using inverse sine, inverse cosine, and inverse tangent. We haven't seen these at all, so I do want to make sure that it is clear enough for you to rewind, pause, and rewatch as needed. And that's going to be more applicable to something like this. So the differences between these two is that in this one, you only have one missing angle, whereas in this one, you have two. In this one, you are given one side, and in this one, you are given two. So these are two examples of something that you may see on your test, and your test, the 6 questions are 1, 2, 3, and then 1, 2, 3. So this is almost exactly what you will have on your test. Before we get started on that, though, we need to cover our fundamentals. Sorry about that. We need to cover our fundamentals. These are the things that you absolutely need to know. And I've said that in class. If you've been there, if you haven't been there in the video, you might hear it. Without this, you will not be able to go near solving these things. So I will do the first one for you to show you what I'm expecting from you. And then give you some time to do the rest on your own. You'll pause the video, solve it, and then check your answers with my answers. For the first one, we want to find the ratio. So what is this going to be solved by cosine? Is this going to be sine? Or is this going to be tangent? The first thing I like to do when doing these is I like to write Sohcahtoa. This is my little cheat sheet. This will tell me opposite, hypotenuse, or whatever the case is. If I have an adjacent hypotenuse, I'll be using cosine. If I have opposite and adjacent, I'll be using tangent. So for this part, I just want you to set it up for me, but you're not actually solving for anything. Looking at the first one here, I'm going to first start off with your reference angle. So in this one is beta. I want to ask myself, what is the relationship to that angle from each of the sides? Is it, so for example, starting with the 4, is the 4 an opposite of beta? Is it an adjacent of beta? Or is it the hypotenuse of this triangle? Well, you know it's not the hypotenuse because the hypotenuse is always on this side right here, and we actually don't have that measurement. We know it's not adjacent because adjacent means next to, so it has to be the opposite. I'm just going to put a little O to remind me that that's opposite. Now I'm going to do the 3. So if I know it's not the hypotenuse, and it's not the opposite because I already named it, we know this is going to be my adjacent. It's also my adjacent because it's next to it. So now that I have an O and an A, and I don't have an H, I'm going to look at Sohcahtoa. Which one of these trig identities uses opposite and adjacent? Opposite and adjacent is tangent. So that means that tangent of beta is going to be opposite over adjacent. So 4 over 3. And that is all I'm asking you guys to do for the next 4. So go ahead and pause the video here. Solve those 4, and when you hit play again, I will have the answers for you. Alright, so go ahead and check your answers in comparison to mine. For this first one that you were doing on your own, I'm going to look at my reference angle beta. I notice my 9 is my adjacent, My 11 is my hypotenuse. So since I have an AH, I used cosine. For the next one, I had opposite hypotenuse. If I had opposite hypotenuse, I used sine. I had opposite adjacent. Opposite adjacent means tangent. Opposite hypotenuse means sine. So for these last two, I didn't label with the O and the H or the A. If you have to, go for it. I just wanted it to be a little bit less cluttered, so I didn't do it for the last two. Okay, so this is the first example we're going to do together. I am given an angle, my right angle, and then I'm given one of the legs, and I'm told I want to find the missing angle and then the two missing sides. So I'm going to separate this just like I did it in class, if you were there, so that I know what I'm solving in each section. In the first, I'm going to go ahead and just solve for my alpha because it's just the simplest one. So for this, I'm going to go back to the very beginning when we talked about an interior angle sum of a triangle is 180 degrees. So that means that whatever my angles are, when I add them up together, it's going to give me 180 degrees. So I can just set that up as an equation. 180 is going to be the 55 plus the 90 for my right angle plus whatever my alpha is going to be. Combine like terms. And solve for the alpha. That would be 35. All right, so when you're given two angles like here, you could just use this to solve for the third one, and that's pretty straightforward. Now to solve for A, it's going to require a little bit more work, and it is what we practiced right above it. You will need a calculator for these two sections, and I recommend you have one of these. If you don't, I will go over how to do it on an iPhone, but you should work on getting a calculator. Okay. So for A, I'm going to go ahead and block the C because I don't need that right now. That's all the way over here. I'm going to work with a 55 because that's what I'm trying to solve for. So just like here, when I started off writing the theta or the alpha or even the beta, I always like to do that angle part first. In this one, it's not theta, alpha, or beta. I'm actually given the angle, which is 55. So that's what I'm going to put in my parentheses. And I know this is going to be a ratio. It's going to be a fraction. So I'm going to ask myself my A in comparison to my 55. Is it my opposite, adjacent, or hypotenuse? Well, we know it is my adjacent because it's right next to it. And then I'm going to also use the 18 because that was given to me, and that is going to be my opposite. I know I'm not going to be using my hypotenuse because that's an unknown, so I'm just going to be using A and O. When I write my Sohcahtoa again, just to keep it more zoomed in and I don't have to go back to the top, I'm going to see which one of my trig identities deals with adjacent and opposite. And that would give me tangent. So I'm going to say that tangent of my 55, that's my reference angle, is going to be opposite over adjacent. So opposite is 18 over adjacent, which is my A. Then this just becomes a solving problem. So to get rid of a fraction, we multiply by the denominator. A tangent of 55 is equal to 18. I want to get the a by itself, so I'm going to divide by tangent of 55 on both sides. A is equal to 18 tangent of 55. I'm going to go ahead and use my calculator for this. So 18 divided by the tangent of 55, 55, gives me 1260, 37. And that is my answer. So just quick recap. Using what we learned here, I did the same idea to find this part here. I used my reference angle of 55. In this one, my reference angle was beta. In this one, it was theta. In this one, it was alpha. In this one, it was 55. Then given the information, what I wanted to find and what they gave me as part of my problem, I was able to set up my equation. And then I just solved for my variable, multiplying both sides by the denominator to get rid of the fraction, then isolating that variable using my calculator. I'm going to do the same thing for C here. So I'm going to cover my A because I don't need it. Again, I'm going to be referencing the 55. So here I am given the opposite. It's already labeled for me from the last problem. And then I'm also given, I want to use my C, which is my hypotenuse. It's directly across from the right angle. So opposite hypotenuse, I'm going to be using sine. Opposite hypotenuse. And then again, it just becomes a solved problem. Okay, so 18 divided by sine of 55 is equal to 21.9739. 1, 2, 3 little dots. And that becomes my answer. So I recommend you guys pause right here to just make sure you stare at it for a second and process. I am going to draw the new one now that you're going to do on your own. All right, so here is the one you are going to work on your own. I want to make sure that when I pause the video to give you time that I keep this so you can keep referencing it if you need to. Remember to use what we already know as well as referencing back to this fundamental section that we went over. So here, go ahead and pause the video. Take as long as you need to solve it. And once you are ready, you press play again and the answers will be here for you to check your work. All right, hopefully you were able to get through this on your own. If not, here is how I did it. Set each one, add them and set it equal to 180. I got that my theta was equal to 20. For A, I covered my C. So I had opposite and adjacent. I used tangent, multiplied to get rid of my denominator, which isolated automatically my variable. So all I had to do was multiply this in. I didn't have to do any division here. And I got this here. For C, when I multiplied to get rid of my denominator, I still had to divide because the C, our variable, wasn't by itself. And then I got my answer of this for my hypotenuse. I said I wanted to show you how to use your iPhone for it, and then I forgot to do it. So let me actually do both of these using my iPhone sideways calculator. So I might need to zoom out. Okay. I'm just going to enter this part here. So I'm going to do 24 multiply it by, so x 70 tangent enter. You want to make sure that you do the enter sign because the number that was right before it is only the 70 of tangent. And then lastly for this over here, I am going to do 24 divided by cosine of 70. So 24, oh, that didn't need a box, but 24 divided by 70 cosine, 70 cosine, and then equal sign. So these are the iPhone instructions. I was told if you have an Android, it will be really similar to the calculator I'm using, the TI-30X. All right, now we're going to go ahead and talk about the third type, the inverse sine, inverse cosine, and inverse tangent. Now, I know that that looks really complicated, but I feel like me as a teacher, I feel like this looks harder than it actually is. For the others, we have started with the angles and then moved on to the side. But for this one, I'm actually going to start off with the side because it's a lot easier. I have two sides here. So if I go back to using, when we did these notes together, the first thing I did to find that missing third side of a right triangle was the Pythagorean Theorem. And I'm going to follow the same concept. So my Pythagorean Theorem is a squared plus b squared is equal to c squared. Well, here I have what my c is, which is my hypotenuse, and then I have one of the sides, which I'm going to name a, because this one is b. So I have 5 squared plus b squared is equal to 9 squared. B squared is equal to 56. B is equal to the square root of 56, and 56 is, what is it, 4 times 14. And I want a perfect square. That's why I chose those two. So I get 2 radical 14 is equal to b. Now, you might not be able to do it in your head like I did, so go ahead and break it up on the side. 56 is what? If you want to start off 2 and 28, then go ahead and break that until you get to the same spot I did. But I feel like that's something we've already done a lot of, so I didn't want to spend too much time on it. Okay, now we're going to focus on the angles. Now, we like the angles in the last problem because it was easy to just use interior angle sum. And then just add and subtract. But with this one, since we're missing both of them, we can't do that. I am going to start off, I'm just going to pick the theta. And I'm going to start off by solving that. So if I use the information that's given, the 5 and the 9, I want to set this up. So cosine of theta is, so I have my adjacent and my hypotenuse, which is why I'm using cosine, and I get 5 over 9. Now this is where those inverses come in. The only way to get rid of a cosine is to do the inverse of a cosine. Like when we're doing the opposite of addition, we do subtraction. Opposite of multiplication is division. The inverse of a cosine is called inverse cosine. It is the cosine to the power of -1. And what I do on one side, I have to do on the other. So when I do that, these are opposites, so they cancel out. And on this side, I am left with just the theta. So that inverse cosine cancels out the operation or the identity. And on the other side, I would be left with the inverse cosine of 5/9. I know that looks really weird, but we really don't do much more with it other than that for now. So let me go ahead and say, so it's right here. I have to do second, and you'll always tell because it pops up, and then you hit your cosine, and it'll give you that purple one, which has a -1, 5/9, and then you enter, and that's it. You get your theta. So we get 56 point, and I like to just keep 2 of them. When it comes to angles, it's a lot easier to work with. So theta is 56.25. Let me do that one more time. In order to cancel out the cosine to isolate my theta, which is what I want to solve for, I have to do the inverse, which is cosine inverse. And what I do on one side, I do on the other. That crossed this out, but it left me with the inverse cosine of -1, of 5/9. I plugged that into my handy dandy calculator, and it gave me just what I wanted. And I only used 2 decimal places. Now I can do the same process over here, but I'm not going to because I can just use interior angle sum. So I am going to do interior angle sum of a triangle is equal to 180. So 180 is this triangle. I have my 90 degrees plus the theta that I just found, which was 56.25 plus alpha. So if I do 90 plus 56.25, I get 146.25 plus alpha is equal to 180. So 180 minus 146.25, 33.75 degrees is my alpha. And that's it. So I used Pythagorean Theorem because I was given 2 sides and I used it to find my third. Then in this one, I use the inverse of cosine to eliminate the cosine and leave me with the theta, which is my variable. That's what I'm trying to solve for here. I just plugged it into my calculator using my second and then the button. So you see the little purple ones on top. Once I got that, I used interior angle sum to solve for my missing angle. And that was it. So let me give you one for yourself. All right, so here you go. Go ahead and solve this one. Pause the video here, show your work. When you unpause, I will have the answers for you. All right, this is what you should have gotten. I did this one first, Pythagorean Theorem, and then I moved on to this one. In this one, I went all the way over here, and this one, I just chose this one. Whichever direction you went in, you should have the same answer. I did inverse of sine, plugged it into my calculator. Once I rounded to 2 decimal places, I solved it over here. What I just realized was that I did 52 here, and then I flipped it to 25 over here. So the only difference would be that at the end over here, you would actually get 48. You don't need 3 equal signs. So this would be your final answer if I transferred these correctly. But that's about it. We will keep working on these. If you have been testing, I'm sorry that this seems so foreign, but you also hopefully have the class videos that I recorded on Teams that will help you out. If not, pause, rewind, and rewatch as needed. Be good, be great, to be beautiful, and I hope this helped.